0.35 just because it's basically looking at graphs and misleading graphs, which we've kind of done a million times already. So I think you should be fine with that. So, all right. So we're going to do measures of location tonight. So measures of location are, they use some weird terms in this book for like different things. It's basically mean, mode, median. Most books will call it the centers of measure. So we're looking for the center of your data in a variety of different ways. First one, arithmetic mean. Big long word for average. Mean and average mean the exact same thing. You'll hear them interchangeably. In math classes and stuff like that, you'll typically hear them as mean. Everywhere else in the world, you'll typically hear it as average. They mean the exact same thing. I think they just wanted to keep everything with M's. So like mean, mode, median, that type of stuff. The formula is exactly as you would think. Add them all up and divide by how many you have. So your X terms of all the values that you have, the N is how many of them you have. So add everything up, divide by how many you have. So let's look at this simple one. So 4, 10, 7, and 15. What's the mean? So we would do 4 plus 10 plus 7 plus 15. And we would divide it by 4, because we have 4 of them. 15, 21, 36. Divided by 4 is 9. So that shouldn't be any different than any mean you've ever been, or average you've ever been taught in your life. Correct? Okay. Everybody remember doing that at least once in your former math career? All right. So regular mean, pretty simple. There's 2 other means we're going to look at. The second one is what's known as a weighted mean. So weighted means are when you've combined your data basically, but the data represents a different number of values each one. All right. So let's say you went out to a fair, you're selling stuff at a fair, and you come back and you have 21s, 15 5s, 3 10s, and 15 20s. All right. If I wanted to find the average value of a bill, I would multiply each of those, like, so 15 times 20, 5 times 10. I would multiply those to find the total money I had, and then I would divide by how many bills I had. Okay. We're going to do a couple examples so you can see how this works. But basically, yes, go ahead.
Sorry, maybe you'll answer my question.
Okay. So the top is the weight of each value times it, add everything up. And the bottom is just how many total you have. Add it up. Now, what was your question?
But how would you write this in, like,
I'm going to show you.
like as a definition that we'll remember instead of just an equation? You know what I
Yeah,
mean?
don't write the equation. You're going to look at that equation and go, huh?
Like, when I do homework, I look back at it.
Yeah, I'm going to do, you'll see in a second. All right, here, let's look at an example. Okay, so we want to figure out Megan's GPA. This is actually one of the places that you'd use a nice weighted average. So the first thing, we obviously can't use letters. So let's change these grades to what the GPA would be. So the B is a 3. A is 4, C is 2, and A is 4. Okay? Step 1, you can't do it with letters, you have to have numbers. Now, how many points did she earn in psychology? It's 3 credit hours and her grade was a 3. So we would do 3 times 3. It's the weight times how many of them I have.
So a weighted mean would only apply to like grades.
Not necessarily. The next example is not grades. Okay. Oh, so a weighted mean is anything that has been grouped. It doesn't necessarily have to be grades. It could be anything that's grouped. Okay. So it could be weights of animals. It could be the number of Hot Wheels cars people have. It's like, it could be anything. So it's when we group data together before we actually have to find the mean. I'm still getting.
You trying to
I'm
simple it for me, but it just can't.
Okay, let me do this example in the next one and see if it gets it. If not, I'll come up with something else that might help. The one place that you typically do use it is actually your GPA. It's just not the only place you can use it. All right, how many points would you get out of probability and statistics? It's 4, right, times the 4. Anatomy is 2 times 5. And then English is 4 times 3. Okay? So I've got 9, 16, 10, and 12. Okay? Step 1. I have to now add all those together. So 28, 38, 47. Yeah. So that formula that they gave you in the last page, that's how you get the top number. You multiply each one out, add them all together. So in this case, she's earned 47 points. Okay. Now we need the bottom number. How many credits did she earn? So 3, 6, 11, 15 credits. So to find her GPA, we take 47 divided by 15. And I think it's 3.2, but I'm going to do it just to make sure. Approximately 3.2, 3.1. So her GPA is a 3.13. Yes.
Can you remind me again why it's divided by 15?
Because she has 15 credits. So your GPA in this case is basic, it's per credit. It's the number, your score that you would have gotten for every credit you earned. So in this case, she's earned 47 points in grades divided by the 15 credit hours. So her GPA is a 3.13. Okay. Okay. Let's do one more. That's not grades. We want to find their average monthly balance from January through March. No. How many days are in January? 31. So when they're looking, if you look at your statement, it tells you your average balance. That's your, they take your balance and they divide it by how many days you had. So it's the average balance over the course of that month was $1,885.67. But there's 31 days in January. So I can't just add these 3 up and divide by 3 because each of the months have a different number of days. However, most people would just add them up and divide by 3 and go, oh, that's my average daily balance. Doesn't quite work that way. So January is 31 days. How many days are in February? Not a leap year. 28. And how many days are in March? 31. Use your knuckles. Literally how I remember it. And I do that often if I can't remember it. All right. So there's the number of days. So how many total days did we have? So add those up and we get 90. Or 90 days. That's going to be the bottom number of my calculation because I have 90 days. Okay. The total number that you have. So in this case, I have 90 days. So now I have to multiply. So in January, I had 58,455.77 because I multiplied the daily balance times 31. Then I take February 13/12/92 times 28. And the same thing for March, multiplied times 31. And then we add those together. So 157,264.96. Okay, so first question. Does everybody understand where those numbers came from? Okay. Does everybody understand the concept of what a weighted mean means? You can say no, it's okay. Like if you truly don't understand, like we could. So the concept is in a typical mean, in a typical average, everything is the same. Okay. So if I wanted to say, what's the average age in here? Okay. I could ask everyone their ages and add them up and divide by how many students are here, and I could find the average age of a student in this class because every one of you are equal in that respect. Okay. In a weighted mean, not everything's equal. All right. So everything has a specific weight attached to it. And that weight could be anything. In the last example, it was credits. The number of credits was the weight. So each class was weighted differently. So when you take a class that's 5 credits, it weights more on your GPA than a class with 3 credits. Okay. And by counterstance, a class with 0 credits doesn't give you anything towards your GPA. Okay. So if you take a non-credited class, it doesn't help or hurt your GPA. So that's the weight. In this situation, the weight is the number of days in those months. Okay. So in a weighted mean, each individual thing has a weight that you have to multiply it by before we could find out the average, because some are worth more than others. Okay. Does that make it a little more sense? Okay. All right. So now I got to do one more step. I have to divide these two numbers to find the actual average daily balance for the months. So I'm going to take the 157,264.96 and divide by 90. And hopefully, I didn't leave the number off there, so I don't have to retype it. And we get $1,747.39. So that is the average monthly balance or average daily balance for each of those months, or for the 3 months. Okay.
So,
No, go ahead.
no,
You sure? Okay. Yes.
For like our science stuff like that. So we have to know abstract facts, like how many days are in like a month, depending on the
yeah,
week.
like, is the test gonna be like this?
Actually, I don't remember what question I put in the test. The test is actually in Hawks already, by the way. If you look at your assignments, it actually is already there, and you should be able to do it's not it's a review test, but you should be able to actually practice it. Okay. I'm going to go out on a limb and go, I don't consider the number of days in a month an abstract fact. Now, you're not going to have to know weird things. Like, I wouldn't expect you to know like a 20-sided die, things like that. Those things, like, those aren't things that everybody knows. I kind of would expect you to know how many days are in a week, how many weeks are in a year. Those are things that I would kind of expect you to know.
Okay, so you like weeks a year? I don't know that.
Yeah.
That's a weird fact that I know.
I know the days
Well, I thought every month was like 30 days. I think on that February they'll come to me.
Yeah. Not every month, that's 30 days. So, random stupid facts, because I have tons of them. The number of days in a month, so we have a Julian calendar. Julian's came from Julius Caesar, which is in Rome. And what they did was when they designed the months, if you think about your months, go back to your Roman emperors, Augusta, Julius, they named the months after themselves, and they took days to make their months more important. That's literally how they ended up making the months. I think it's stupid. I think every month should have 28 days.
Is that the same where if you would have the same number of days, you did 28 days and then out of the 13 months?
Yep, you could.
Move it, you have like the perfect number.
Yeah, except you'd be off by one day. But I consider that day 0, which is New Year's every year. And you don't have a problem. But yeah, that's literally how the things are. And I don't think anybody would want to go to 13 because people have a strange fear of the number 13. It's weird. So, but yeah, 13 months and 28 would be perfect. Your birthday would fall on the same day every year, no matter what. You would never have to worry about it. We wouldn't have people having leap years and stuff like that. That would no longer exist. So, all right. We're going to go back to this problem for a second. Because I just want to torture you.
Does everybody know how to count their knuckles for the days? January, February, March, April, May, June, July, August, September, October, November, December. Your knuckles.
I put them next to each other.
Your knuckles are 31. Your divots are the other ones.
Where are my numbers?
You guys didn't learn that?
I like that's literally how I learned it, and I still don't to this day.
You remember how you learned to plan?
It was some acronym, but
Binary, output the mother, third brother, something like that.
yeah. I was such a space geek when I was in school. Like, I actually knew them before the teacher even taught us them. Yeah, like, I really like space. So, all right, we're gonna look at. There's a second part to this question. So, I was one of those strange students that. So when I was in college, long ago, I was taking a class, and it was a math class, but I really didn't like the class. It just wasn't one of those classes that I enjoyed taking. So, but I had to take it for my major, so I took it. I walked into the class. I knew my grade, what I needed, and I knew the teacher's grading policy. So I sat down the night before and figured out what I needed to get on the final exam so I could pass the class with the grade I wanted. So I can't remember what I had, but I wanted to be in the class. And I figured out that I needed a 20 on the final exam. So I needed to go in, write my name on the test, and do the very first question on the test. Get the question right, and I was done. So I studied to make sure I could get that one question right. I literally went in, got that question right, handed it back. She goes, "You're done?" I'm like, "Yep, I got the grade I wanted," and walked out the door. I'm like, I'm done. It was abstract algebra. Don't ever want to take that class. It's just. But so a lot of times you will have certain things like you want to figure out, like, okay, this is what I want. What do I need to get that? And I can guarantee at the end of this class, at least 2 or 3 of you are going to say, what do I need in the final to get an A or a B or whatever it happens to be? Like, I'm going to get asked this question because I do every year. Oh, talking about tests. I don't think I told you guys this. This is actually kind of a nice important thing. As long as you get it, if you can get an A on all the tests, and as long as you have an 80 in Hawks for your homework, which I think is the minimum you could actually get. I think you have to get at least an 80 to certify that you're done with it. So as long as you've done all the assignments in Hawks and get the 80s on them, and you have an A in all your tests, which means a 92 or above, you're exempt from the final exam.
92 or 90?
92, an A. Now, the other way also works. What I also do, so that's the way you can get out of the final exam. Let's say you have a horrible test. One day, so there's only 3 tests. You have a horrible one. You do better on the final than that test. I take your final exam score, I will replace the lowest test grade. Okay? Because I figured if you could pass the final exam, you obviously should have been able to know that stuff at some point. You already learned it, so you're good. So I will take your final exam and I will replace the lowest test grade you have. Okay? So that's how you can get out of it. And if you have to take it, it will benefit you because it'll increase one of your other scores as long as you do better on the final exam. Okay? And as I was saying, Chapter 4, the review test is already in Hawks. So I think you can go into your assignments and see it. It should be available. It should, and you can do it as many times as you want. Okay? And I basically just printed out a copy of that test. So it's the exact same style as those questions. And I don't think I picked any that were really, really strange wording ones. Because I went through and I picked. It's only 10 questions on the test. So, all right. So Megan wants to have a GPA of a 3.4. So in this case, we don't know what her anatomy score is. Okay. So we're going to call that X. All right. So we don't know what her anatomy score was. So her other scores still exist. So that's still 4. That's still a 4, and that's still a 3. So we've got those. We're going to do the exact same thing we just did a minute ago with the calculations, except this time we have to do a little bit of algebra. Sorry. Same concept. Let's multiply. So I've got 9, 16, 5x, and 12. And I got 15 credit hours. So I've got 9 plus 16 plus 12 is 28, 37. So, yes.
How did you get 5 on C? Because I thought C was 2.
No. C doesn't exist. We don't know that grade. No questions. I'm just kidding.
So on the one with money, right?
Yep.
You added up the stuff that you, I guess, weighted or
Mhm.
whatever, or you transferred it to something different.
Yep.
On this one, you're adding up credit hours instead of the 3, 4, and 4. Why? And you did that on the other grade one as well.
Right, because the credits are what is the total. That's what we're doing it by. So your GPA is based on per credit.
You didn't make that up. You've done
It actually says
Yeah,
that.
it says
Yeah.
A.
That wasn't requested. Because I did it backwards. So like in this one,
And that's when you added up the days of the month.
Yeah.
right.
But that's standard. January's never been paid.
No. That wasn't what she was asking. Yeah. No, I got it. So you're fine. You're fine. So in this one, we were looking for the average daily balance. Okay. So the daily was the bottom. That's why I added up the number of days. Okay. In this one, GPA is per credit. So the credit is my bottom one, not the grade. The grade is the top, the credit's on the bottom. Okay. So whenever you're looking at it, whatever you're weighting, it's per. Like it could be per square foot or per yard or whatever it happens to be. That's always your bottom number. Okay. The weighting and stuff like that, that's going to be your top thing. All right. So now going back to this question, does everybody understand? So you had a question of, well, what happened with why is the C not 2? Because in this question, the way the question's asked, they want to know what she needs in the anatomy class to get the grade. So we don't have that C. So she didn't get the C yet. But she wants a 3.4 GPA. So we need to know what grade she needs in anatomy to get her 3.4. Okay? So she's earned 37 points, right? In those other classes, correct? And we don't know what the anatomy class is. That's why there's an X there. And we're dividing it by 15. So how would you go about doing this problem?
Multiply by 15.
You could guess and check. So, and actually in this one, it wouldn't be that hard because you can only do a 1, 2, 3, or 4. So it wouldn't be hard to guess and check. So when you're looking for these, a lot of times is let's figure out what the total number of points you need is first. And that's what the multiply by 15 is. So if I take the 3.4 and I multiply by 15, I can figure out how many points I need, and then we can subtract off. That's why a lot of teachers will do their class out of like 1,000 points or whatever else, because it's a nice, easy number to divide by.
So you just subtract 12?
No.
Okay, I misheard what you said.
Yeah.
I was like, why are we subtracting?
No, not 12. So we're going to multiply 3.4 times 15. Somebody do that real quick for me because I don't feel like opening it. Thank you. And now we're going to subtract the 37 because those are points I've already earned. So how many points are left that I need? 14. And then we can divide by 5. So X is approximately 3. So she needs a B.
Maybe you want to round down.
But so if I rounded down and said you got a C, is she going to get the 3.4? Right. So in this case, you'd want to round up. Or actually, in this case, it's approximately 3. They were only doing whole numbers, so this one you could get like a B minus or anything else in it. Technically, I think you could get a B minus because that's a 2.8, if I remember right, which should be fine. So she needs a B. That's how you'd actually do your figure out your final exam at some point. Your weights would be the percentages. That would be your weights. Yes.
So if it's 14 divided by 5, how would you get like X equals 3?
I get approximately 3.
Approximately. So
It's 2.8. But again, in this one, it was a 1, 2. It was a 2 for C, 3 for B, and 4 for A, and obviously a 1 for D. There was no points, so she needed a B in this class. In your grades, you need a B minus because that's a 2.8. So you need an 80 and 81, or yeah, you need an 80 or an 81, right around there. That's why, if you notice, I put here the little squiggly equal sign. So this actually is a very important symbol for probability and statistics. That means approximate. Okay.
What is it?
Yes.
I'll be like equals with the slash through it to show like.
Yep, not equal to.
And people don't know what it.
Yes, people don't. That means approximate. One little squiggle you'll never see in here, but in geometry that's similar. But yeah, that one you're going to see a lot because we do approximate a lot of things. We do estimate things in the stuff. So you will see that symbol quite a bit. Okay. Are we good with weighted mean? Now you know why I said this is going to take longer today. It's okay. All right. Trimmed mean. So have you ever had a teacher who gave you all their homework assignments and everything else, and they say they're going to drop the lowest 2? Okay. That's trimming. All right. Because then they're going to take the average of the rest. If you ever watch like figure skating and old school gymnastics and stuff like that, or actually diving does it too. They'll cut off the highest one and the lowest one. And then they average the ones and the other ones. That's what trimming your mean is. All right. So when you're looking for a trimmed mean, you're cutting off a certain percentage of the values from the top and the bottom.
So is it a value each time?
Not necessarily. It depends on how many values I have. So they will typically tell you a percentage. So like in this case, it was 10%. So if I had 10 values, yes, I'd cross off one at the beginning and one at the end. But if I had 100 values, I would cross off the lowest 10 and the highest 10. And I'd average the ones in the middle. Okay, so you basically eliminate 10, or actually it ends up being 20% of your values because it's the highest and the lowest parts. Okay, so you want, why would we want to do that? Yeah, it eliminates your outliers. Okay, and that's can cause major issues with mean. So out of all the values, mean's the one that's the most affected by outliers. So a trimmed mean basically eliminates that and still gives you a good estimation of what the mean should be. Okay. All right. So they want to find 10% of the trimmed mean. I think there's only 10 values here, if I remember right. Yes. And they are in order, so we don't have to worry about that part. They found the mean of these numbers is 25.5. So we're looking for the trimmed mean. So I'm going to cut off the lowest number and the highest number. Okay? Because it was 10% and there's 10 numbers, so that's one number I'm cutting off from both ends. If I said 20%, how many numbers would I cut off from both ends? 2. Okay. Most of the time when you see trimmed, it's either going to be 10 or 20. Most of the time it's 10, just because it's literally just to eliminate the outliers. All right, find me the mean of those numbers. This is not a weighted mean. This is just a straight mean. And that's not the answer. Because that was the answer before I cut them out.
23.
No, that's median. So when you add them up, what did you get? Yeah, so you got 197 when you add them, and we're dividing it by how many? 8. I have 8 of them now. And then your answer is 24.63. Right around. Actually, we would literally, because there's only one place, we'd only round to one place. So 24.6. No, so the trim is always to both ends. So since it's a 10% trim, I'm trimming 10% from the bottom and 10% from the top. Okay. Good question. All right.
No, I asked that question because I'm like, you know what, it's just.
You can always ask your questions. I don't mind answering questions. All right. They just changed one of the, they just changed the numbers. Okay. So the mean for this one's 70.3. All right. 10% trim. Find me the mean with this one.
Oh, so take, oh, wait, okay, never mind, you're second to it.
Yes. I gave a test to a high school class once. All the answers were on the board. It literally said answers to test 1 through 20 and had the letters next to it because it was a multiple choice test. I had a kid turn in the test blank at the beginning. He says, came up because I can't do any of this and turned in the test blank. I had a kid about 5 minutes later come up, Mr. Baker, do you know all the answers on the board? I'm like, yep. Do you understand the kid before you turned in the test blank said he didn't know how to do it? He goes, oh my God. Okay. So yes, if you looked at these are the same numbers. We're going to cut off which numbers though? The 16 and the 490. So you should have gotten the 197 divided by 8, and it comes out to be 24.6 again. The reason why was, if you look at it, the mean of the set of numbers before was 25.5. When we took away it, we got a mean of 24.6. That's pretty close to the mean of my original values. In this one, my mean was 70.3. By trimming them off, my mean goes down to 24.6 because we eliminated that outlier. All right. So by trimming it, we can get a more realistic answer for my mean without having the outliers screw up my data. Okay. Speaking of outliers, outliers have a very specific meaning. It is a data value that's extremely different from other measures. Now, there's an actual definition for outliers that they might go in later. I'm not going to tell you it now, like an actual formula to calculate it. But most of the time, you can figure out it's just going to be a number that's drastically different than the rest of them. Like that 490 was pretty obvious that that was an outlier.
Like you know, the old lady back there struggling.
I was going to say, I can hit the light.
No, I'm gonna sit up front now.
Okay, I'm sorry.
That's-
It's because it's getting darker outside earlier. No, they're not. No, never passed. Nope.
Really?
The House passed it, the Senate did not. Or wait, I think the Senate passed the House. One of them did, but it was never actually passed by both and signed. So we still have daylight savings. All right. Now, there's one other piece to this that's important. It says measures that are not affected by outliers are said to be resistant. Just because Hawks, I know, uses a lot of definitions in the things that you guys see, this is an important thing. So when you're looking at measurements, so like the mean and weighted averages or weighted means are not resistant because they are affected by outliers. However, a trimmed mean is resistant because the outliers can get cut off. Does that make sense? So like that was where we were looking here. By cutting off that value, this was affected by that 490, but the trimmed mean was not. Okay.
So just it needs
Yeah, unaffected, or not as greatly affected. Yeah, let's do this one. All right. So what level of measure does this data possess? So what type of data is this? The units, not the days. Is it quantitative or qualitative? Quantitative, it's a number. Is it nominal or ratio? Oh wait, is it nominal ratio or ordinal and ratio? Nominal.
Wait, it'd be interval or
Oh, interval. Sorry, interval and ratio. Is it an interval or ratio? Ratio, because this one does have a 0. That would mean something. They didn't do any units that day. Okay, so I want you to. So there is 20 values here. Okay, I want you to calculate my 10% trimmed mean. While you do the 10%, I'm going to do the 20%. And these are not the same values as before, so you have to do it this time. No, for average, you do not. For the ones I'm going to do next, you will, but not for average. So you're doing the 10% one.
I was gonna ask how many numbers there were at my.
20. Okay. Wait. There's only 118. Okay. So how many numbers did you cut off? 2 from each end. Okay. So you had 16 total numbers left.
No, 1%.
There's 20 numbers.
Is it 2 for each?
Right. So when you're doing the trimming, like when we had 10 numbers, right? So in the last one, this one, when we had the 10 numbers, we cut off 1 from each end because 10% is 1.
I just,
No, it's fine. That's actually why I did this one with the 20 numbers, so that you don't. So since it's 10% of 20, that's 2 numbers. So I'm going to cut off 2 from the end, from both ends. You're okay. It's fine. So I'm cutting off the 20 here, the 20 here, and then 119 and 118 would be the numbers I'm cutting off. Does somebody have the sum of them? Nobody added them all up?
I did, but I did it wrong.
Oh. Gotcha. 1741? Oh, 21? And you get 108 if we round. Okay. So this is why. So we'll go back so you can see this. So if you look here, this is how we find the 10% mean. Arrange the data in order because you kind of need these in order, or you don't necessarily have to, as long as you can find them. You're going to delete the lowest 10% of the values and the highest 10% of the values, and then calculate the mean of the remaining. So for 10% of 20 numbers, that's 2. Too low, too high. If I was doing 20%, I would cut off how many from the low end and how many from the high end. 20% of 20 is 4. So I cut off 4 from the low end and 4 from the high end. Okay. So if you look at the numbers, what jumps out at you of those numbers? Yeah, day 4 and 5, there was like next to nothing there. They happened to be sick those days and really weren't performing very well. So are those values indicative of their typical production? Yeah. So if we trim those off, that's the 10%. We trim off the top and the bottom. You can't just do one end. You have to do both ends. Otherwise, it's not fair. It doesn't give you a good representation of it. Okay, so you have to do both ends to make it equal. All right. So by doing both ends, we got the 108. When I did the 20%, I got 107. Which one of those ones would you think is a better estimation of her work? They're both very close, but if we were literally just looking at cutting out those two 20s, because those are really the only 2 bad days they had, the 10% makes more sense in this situation. The 20%, I think, cuts too much. Okay, because it cuts a couple other good days out that she had. Okay. This is where we would use those trimmed mean applications. All right.
Still trying to think where I could use it.
You might not. What I used to tell the high school students, I'm like, in all honesty, you might never do it. However, you will see this all the time. And if you remember, the one thing I told you, I want you to get out of this class at the beginning. What was the one thing I told you I want you to get out of this class? Right, to not be fooled by statistics, to be better thinkers. Okay? So as long as you get that out of the class at the end, you're going away with a skill that you can use for life. Here. The rest of the stuff, you have to pass the class. So, I will throw some problems of healthcare in there at some point because I do have some problems a little bit later on for some of the higher stuff.
I mean, this could make sense if you were counting like productivity for like registration.
Or even like just patient levels.
Yeah, that's what that.
Yeah, you could cut off like, okay, you don't want to look at your lowest days, but those upper high days also could be an anomaly. So if you cut those out, you look at the actual internal group of that might give you a better estimation on the typical number of patients you would see on a regular basis. So there is use cases for it. It's just a matter of finding them. And unfortunately, what ends up happening a lot of times is you don't know the use case until it comes up. And then you either have to figure out how to do it then, or you remember how to do it. My friend is a nurse, and she called me up the other day. She goes, I don't remember how to do, she was doing dosage for a medication. And she says it was 100 milligrams per it was 15 milligrams per kilogram or something like that for their weight. And she needed to change it to milliliters to give them the dosage. And I'm like, okay. And she didn't give me one piece of information, which made you give her the wrong answer. But she couldn't remember how to do it. She learned it in nursing school. It was literally on her tests, but it had been a while since she did it. She just didn't remember. And as soon as she got an answer close, she goes, oh, now I remember how to do it. She clicked because it was there. At some point she had learned it. It was in her head somewhere. It just wasn't right at the front of her mind. So that's where a lot of this stuff comes in. It's like you might never use it, but one day you're going to see it and like, oh, I remember it. It's like, I remember how to do that. Or, oh, wait, there wasn't there one that I could cut things off and make it easier? That type of stuff comes up. So, all right. Yes,
I don't know if it's still
you can.
But why is it like 10%, but 20%? Why do you only take out 4 quarters?
I took out 4 for the 10% because it's 10% on the low end, 10% on the high end. Okay. I took out 8 on the 20% because it was 4 from the low end and 4 from the high end because it was 20%. So the 10% doesn't mean the number I'm cutting off. It means the numbers I'm cutting off on each end. That's where it's 2 on both ends. Otherwise, I'd have to cut off a half of one if I only had 10 numbers, and that wouldn't make sense. All right, what are the other two means? The other two things that you learned when you talked about mean? Median and mode. What's median?
So until you find the middle one, or you find the 2 and add that up and divide by 2.
Yep, exactly. That's median. This one, you have to have them in order. So median, the numbers have to be in order, and you're looking for the middle number. If there is an odd number of them, you will have an exact middle number. Okay, I can go back so you can actually, if you really want to write down the actual definition. If it's an odd one, it's whatever number is right in the middle. If it's even, it's exactly as you said. Add them up and divide by 2. Okay.
That's. Add them up?
Yes, add them up and divide by 2. The 2 middle numbers. Yeah, just the 2 middle numbers. You're always looking for the middle. So yeah, you're taking the average of the 2 middle ones, which should always come out to be that a number there or a half. Like it's never, you're never going to get crazy decimal for those. All right, here's a set of numbers. They're not in order. So the first thing you have to do is put them in order. And that's, as crazy as it sounds, don't forget to put them in order. I have seen people find median with them up put in order. And you won't get the right answer. Do not forget to put them in order. The next one is 72.
Where does the 60? That's 65.
65.
Oh, I thought it was a 3.
Okay. It looked I had right and it looked like a 3 and I erased it and put the 5. I'm like, wait, I know I was gonna say I thought I fixed that one. 79. What's the next one? 3, 5, 88, 90, 94, and 98. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got all 10. Okay. I don't care how you find the median, in all honesty, how you actually go about crossing them off to the middle. I typically do this. Up, 2 left. So you're going to add those 2 and divide by 2. So 83 plus 85 divided by 2 is 84. And that's your median. All right. Any questions with median? And there's nothing crazy about median. That's literally the only way to find median. So no other crazy ones like there was for the average. Mode. What's mode? One that comes up most common. So in this case, my mode is what? Yes, because that's the number that appears most often. What if I had another 1 there? What would be the mode?
1 and.
Yes. Yeah, 1 and 0. Okay. So you can have more than one mode. Okay. It's called bimodal or multimodal. So you can have more than one mode. All right. So if there's more than one that has the exact same amount, you're going to list them both. Otherwise, it's the highest one that appears. Okay. Any questions with mode? Good. Those are the easy ones. All right. Now let's actually look how this stuff kind of relates to each other. This is the curve you're going to start like have nightmares about. You're going to see this curve so many times. So your bell-shaped curve distribution is a perfectly symmetrical curve. Okay. Any teacher who tells you that they grade on a curve is lying, because if you grade on a curve, you grade based on a bell curve. And that means one person in the class has to fail and one person in the class gets an A, no matter what the grades are. That's a true curve. Nobody does it because it's completely and utterly unfair to the one person. Even if you got like a B, you'd fail because you were the lowest one in the class. But that's a true curve. So the bell curve, your mean, your median, and your mode are all right in the center. The number that it would appear most often is in the center, and your mean and median are identical if it's perfectly symmetrical. If it's not, it's skewed. It's positively skewed or right skewed if it pulls your, this is what we were talking about the other day, if it pulls your mean. Okay? If your mean's pulled to the right, it's positively skewed or right skewed. If your mean's pulled to the left, it's negatively skewed or left skewed. Okay? All right. This table, this is that outliers thing. The only thing that is sensitive is your mean. We kind of already talked about that one. I'm actually going to eliminate that graph because we don't really need that graph. This is the more important one. All right. So remember, we have two types of data, right? Qualitative and quantitative. Qualitative is non-numerical, or it's descriptive type data, right? You can't find your mean of those, right? You can't do the mean of qualitative data. You can find your mode always, okay? And if you can put the data in order, okay, which means it's ordinal, there is a possibility of you being able to find the median. All right, so if you can put the data in order, you can find the median. Even if it's like star reviews, like 1 star, 2 star, 3, you can't add, subtract, like find those things, but I can easily find the median of those values. If it's quantitative, so if it's the numerical, I can always find everything. Mean, mode, median. Doesn't matter if it's interval or ratio, I can always find those values. Almost done. One more slide. Out of everything, tonight's class should be the last one that you've actually seen prior to today. I'm going to go out on a limb and go, the majority of you probably have not seen what it is in 4.2. Just ask questions. And I'm going to, like, I went a little faster with this stuff because I know you've seen this stuff before. I spent a little more time on the weighted and trims, but I'm going to go slower on the other stuff because I know you have not seen any of that. So, all right. One of the most important things you can do is figure out what calculation you're going to do for the data. So if a doctor is analyzing increases in blood pressure, would they be most interested in the mean, the median, or the mode of the systolic blood pressure, which I believe is the top number? Is it the top number? Okay, thank you. Yeah, in this case, I'd probably, well, they're just looking at the increase caused by it. So, but yeah, the average, you could look at that. Car manufacturers trying to decide what color they should offer the new sports coupe. What should they be looking at? What's the only one we can do for this? Is mode. Yeah, the only thing we can look at is the one who's the most. All right, because it is not numerical, it's not qualitative or quantitative, and I can't put them in order. So the only thing you can find in that is mode. Manufacturer of chocolate bars is interested in knowing how people rated chocolate from best, above average, average, below average, or worst. Which one would be the best one to look at it though? Okay. Yeah, you can make an argument for either mode or median. A realtor is interested in setting house prices versus home sales. Would they look at mean, median, or mode for the prices of recent home sales to be the best measure of central tendency? What was it? Median. Why? What can come up when you're looking at house prices? Outliers. And which one is resistant to outliers? Median. Okay. All right. That's it. You should be able to do 341. I am here every single day sitting down in D207 from 2 o'clock on. So you guys, huh? Oh, sorry, not every day. Every Tuesday and Thursday before this class. Before this class. So every Tuesday and Thursday, I take that back. All right, in D207, you're more than welcome to come down and bug me. I have no problem helping. No problem going over problems and everything else with you.
Can I take a picture of the graph that was on the left?
This one?
Yes.
Yeah. No problem.
Like, that is.
No, yes.
Will there be like a physical review?
Yeah.
Okay.